I was like, I don't remember how to do any of this. So then I went looking in my notes. I could not find my notes for some reason.
Oh, well, hopefully. Well, did you go get everything out of your locker, or do you still have things at school?
No, I got all my books out of my, like, books and notebooks out of my locker.
Yeah. Yeah.
So I don't know where those notes are, because I remember taking them, but, like, I just couldn't find them.
Yeah. Oh, Noah decided to come study with us.
Told me to remind him.
So funny. Morning, Noah. Hanging out with us?
Hola.
Just hanging out, learning some math. Well, I don't know where Emma is, so we're just gonna start, and then I'll let her in a second. I've started recording. Okay. I think I'm gonna go to. Okay, that's not.
Were you able to talk to Miss Harris?
I was. She said that she had to ask Mr. Olson about it.
Oh, okay.
Okay.
So that's the only answer that I have so far.
About what?
About whether or not Noah and Abby had some thoughts about post prom, and Mrs. Harris didn't know if they were going to have it. Of course, as soon as I get here, then somebody comes in. Coming back. Admit. Does it let Emma in?
Yep.
Okay, good. Good morning, Emma.
Morning.
Okay, here we go. So we're starting at number one. Number one is a limits question we're going back to. But I will have you know that this one is on there on purpose. Like, this is one of the ones that Kaskaskia was like, you have to have this on here. So I was like, all right. So x squared plus 5, x is less than or equal to 2, and then 4x minus 3, x plus 3. Now you have your graphing calculator at your disposal. So one thing you guys might have done is feel free to just go ahead and graph these two things, right? I'm going to do them in different colors, but that person in too. So if you guys want to start graphing those while I let this person in, Daniel is coming in, then go for it. But to be honest, what I'm doing is I'm looking at what the question asks for. So part A is wanting to know what's the limit as you go to negative infinity. B wants to know what's the limit as you go to 2 from the left. C wants to know the limit as you go to 2 from the right. And D wants to know the limit as you go to positive infinity, I believe. So that means that really the important part of this is what's happening at 2 and then what's happening at the ends of the graph. So like when I go to graph x squared plus 5, I actually know that 1, 2, 3, 4, 5, this is a parabola that goes through here, but I'm going to want to specifically figure out where this thing is right here at 2, because this is a parabola that looks like this, and it's when x is less than or equal to 2. So you can graph the parabola, but you might either want to just plug in the point 2, right? Plug in 2 here and go, oh, 2 squared is 4, 4 plus 5 is 9, right? To be like, oh, this is at the point 2, 9. That might be really, really important that you know that, right? And then you can do the shape of the parabola because the limits it's asking for is 2 there. And then this one, honestly, this is gross. I know that there's an asymptote at 3, or no, there's an asymptote at negative 3. Just kidding. But there's a horizontal asymptote right here. So what I might do for this one though, is again, I might just plug in 2. Like I want to know where this thing is at 2. Let me let some people in. Okay. So if I plug in 2 to this thing, what do I get? I get 8 minus 3 is 5 and 5. So I guess I get, when I plug in 2, I get 1. So at 2, I'm right here at 1. And then the question is if this thing goes up or down from there. So I might plug in 3. 12 minus 3 is 9 over 6. That's 1.5. So this thing goes up to 1.5. So my guess is this thing looks like this. Can you guys verify that?
Yeah.
By your calculator. Cool. Let me stop share for a second to make sure that I got everybody. Do we have Daniel and Will? Okay, great. All right, we're continuing on going. Here we go. Oh, wrong one. No. Here we go. All right. So we're on number 1, everybody. We need to get started because we got a lot of ground to cover this hour. Okay, so here we go. So everybody's feeling good about that graph now? Pretty chill? Use your graphing calculator if you want. So now we just have to review limits, but it's good to have that graph drawn. So what is the limit of this thing as you're going to negative infinity? So looking to the left.
It also has like the second equation has like a little one up in the corner on the left side, like
Right,
a little
so-
curve.
Yeah, so basically I'm going to do this for a second. I'm going to erase this, but doesn't the blue one look something like this and then look something like this? Is that what you're saying? Yeah, so remember, basically this is a piece function. So when you graph it, you don't need those parts because you only want the part that's greater than 2. So now that I've kind of done this, even though I graphed them in different colors here, I'm just going to trace them in orange because our function is actually just the parts that we've graphed. So it's just this. So that means this function goes like this and it goes like that. So as you go to a negative infinity, so as you go left forever, where's this thing headed?
Infinity.
Yeah, it's just going up forever. So this orange arrow would go up forever. So because that's headed to infinity, this is the answer to part A is infinity. Now you could actually put does not exist if you guys remember that, because does not exist is the same thing as infinity. Like it doesn't exist, but we're describing it with infinity. So that's what's going on. These ones are a little bit more tangible. Where is this going when you approach 2 from the left? So approaching 2 from the left means from the left side. So what is the height of this thing as you approach it from the left?
1.
Oh, that'd be from the right. Good. So 1 is from the right. So from the left is 9. Yes. So from the left is this guy right here, because from the left means the parabola side. And then Abby, yeah, from the right is the 1, right? Because even though it's an open circle, that doesn't matter. It's a limit. So it goes to the right, it goes to 1. And then where is this thing leveling off at as you go to positive infinity? 4. Honestly, a bunch of the ones after this are not as hard. This was the heavy hitter. So let me pause on this one for a second. What questions do you guys have on this one?
So this was just various limits, right?
Yeah.
Limits at different points.
Here, yeah, just limits. Good. Any other questions? Sweet. Moving on to number 2. That one was an important one, though. Number 2, I think some of these ones coming up will get a little bit easier. So number 2 says, find the equation of all lines tangent to y equals x squared minus 4 at the point 5, 5. So what do we have to do to find a tangent line again? Do you guys remember?
You need the point and the slope.
Yes, actually, this, I shouldn't say at here. This is through, which makes this one a little bit more challenging than
For
at.
those, do you switch like the x and y and then solve to get the other equation, or?
I thought you had to do just the derivative.
Yeah, we got to do the derivative first, I think, right? Y prime would equal, what's the derivative of x squared minus 4?
2x.
2x. So this is the slope. And then here's the sad thing is they actually don't, like, we still don't have the slope. What we have is y minus 5 would equal whatever the slope is, x minus 5. This one is gross. I wish it had said at the 0.55, because that's probably what I'm going to do on your final. I'm not going to give it, because at the 0.55, we could just plug 5 in for x and find the slope is 10. But here, the slope is 2x. So this ends up becoming gross, because what I need to do to find this, I believe, is I need to replace the m with 2x, because that's what we found the slope to be. And I need to replace the y with this. And then solve this. This is gross. Yeah, this one's actually a lot grosser than what I would give you. I apologize. I'm going to distribute this. I'll show you more like what I'm going to give you on the next one.
Oh, but that works out fine.
But this one's, I mean, it's not horrible because it's still solvable, but. And would everybody, so that was gross. Is everybody okay with plugging the 2x in for m since it's the derivative, it's the slope, and plug in x squared minus 4 in for y since that's the equation?
Yeah.
And would you guys know how to solve this bad boy from here?
Yeah.
It doesn't factor very well.
Sweet. Bring it over here. So then you have 0 equals x squared minus 10x plus 9. And I think that's really lovely, right? What times what gives you 9?
1 and 9. And
Boom.
Negative 1, negative 9.
And get 1 and 9. And then what did it want to know? It wanted to know, find the equations of the lines. So that means it wants essentially your final answers that it wants is y minus blank equals, your slope, x minus blank. So that means it wants the equations of the lines with 1 and 9 in it. So that means I can put in my first one, so we'll make the first one pink, right? If I use 1 for x there, what's the slope and what's the y value when I'm using x equals 1?
The slope is 2.
Good, because I plug it into the 2x, and then I can plug it in up there. 1 squared minus 4 is negative 3. So it'd be plus 3. Nice. And then somebody else give me, what do I get when I use 9?
18 and 14.
But the squared. 81 minus 4 is 77.
77.
Yeah, that's gross. Ew. I'm actually going to tell you if you guys want to make a note on your sheet. This one's actually harder than what will be on your exam. And I'll show you the one that will be on your exam, like more of what it will look like on the next one. So just make a note on there. That's a little bit tougher than what's on your exam. Any questions on that one?
I don't think so.
Sweet. So number 3 is definitely more like what's going to be on your exam, especially based on what I added off to the side. So it says find dy dx when y equals x to the 4th minus 5x cubed plus 2x. And it said find dy dx, and that's really easy, right? Everybody, what's dy dx on this?
4x, x to the 3rd minus
15x squared plus 2.
Nice. Everybody feel good about that? And then do you guys see where I hand wrote in there? I said also find the slope of the line. I should have put tangent line at x equals 6. What do you do with 6 then?
Plug it in.
Yeah, literally just plug it in right to the derivative. And the reason I had to add that is because the Kaskaskia, this is another one that they stress. They're like, we just want you to be able to find the slope of the tangent line at some value for x. And I was like, well, there you go. So you can just plug x in, and this is just a big number. I don't know what it is off the top of my head.
It's like 326, I think.
Sweet. And good news is you have your calculator. 326?
I think so.
Oh, because you take it times 4. Got it. Yep. That makes sense to me. And everybody, here is why the one right before was harder than what's going to be on your final. Like on your exam, I would basically say, write the equation of the tangent line at 6. And that would be where you'd be like, oh, well, now we do y minus something equals something x minus 6. And 326 is our slope now. And then to find the y value, you just plug 6 in where?
The original.
Yeah, the original. So that's more like what I'm going to give you on your final, is I'm going to say find the tangent line at a point, not find the tangent lines that pass through this random point. That's harder because you got to do more solving. So as long as you guys can do that, you're fine. Any questions on that? Did you guys do well on that one?
Yeah.
Sweet. Number 4, I'm hoping you did well on this one. You got to find dy dx What do you have to make sure you use on this one?
Quotient rule.
Yeah, so low, see if you guys got the right thing. So low and then d high is 2x minus high. D low is negative sine x all over low, which is cosine squared x. You can totally leave it like this, okay? If you wanted to simplify, you should have 2x cosine x plus sine x times x squared minus 5, or you could distribute the sine all over cosine squared. But this or this will be sufficient. Everybody remember quotient rule?
Yeah.
Sweet. Eli asked before some of you guys got here if you guys get a note card. You do not get a note card, but it's pretty much the only formulas that you would have to know. We'll make sure we hit them on this review packet. But it's things that you've already done as well. So, boom. Oh, I like number 5. So number 5 is another derivative, but it's implicit. So this is where we got to use our dy dx's, right? So I've got to use product rule on this side, right? Because I've got 2 different things, but I'm gonna have to use my dy dx's here. So derivative of x squared is
2x.
times the 3y minus 5 left alone plus x squared left alone. What's the derivative of 3y minus 5?
3 dy dx.
Nice, just 3, but you have to attach a dy dx. I like it because of the and then equals, over here we don't need any special rule because there's no product quotient. What's the derivative of y cubed?
30y squared dy dx.
Nice. And then minus 1, right, everybody?
Yeah.
Sweet. Now what I'm going to do is I'm just going to distribute and make this look a little bit nicer, because the one thing that you guys will have to do is get the dy by dx by itself. So you can't leave these by like as they are, because you got to get the dy dx by itself. So I'm going to distribute the 2x and get 6xy minus 10x plus, I'm just going to clean this up a little bit, 3x squared dy dx equals 3y squared dy dx minus 1. And then I'm going to add the 1 to this side and subtract the 3x squared dy dx for this side. And so on this side, I'm going to have 6xy minus 10x plus 1 equals, and on this side, I've got 3y squared, right, dy dx minus 3x squared dy dx. But this is where I pull out the dy dx, right, from both of these, because then I can divide by this. Is that looking familiar to everybody?
Yeah. That looks like I'm.
It's been a while. Any questions on that one?
We just leave our answer like that.
Yes, that you can leave your answer like as long as you got dy dx by itself.
Okay.
Number 6, sorry, it's got a 4 in it. It's nice that they gave you a multiple choice, but this is probably one of the ones where it's a random formula that you do have to bring back. So what did you guys get? What was your either guess or you are confident of the right answer for number 6?
I had E.
I do believe E is right, because remember 4 to the x kind of works like e to the x, right? The derivative of e to the x is e to the x. Derivative of 4 to the x would be 4 to the x, but it is a negative, so we'd have to attach the derivative of the inside, which is -1. Kind of like if this was e to the 3x. If you guys remember, it'd be e to the 3x and you attach a 3, right? So that's working. But then whenever it's e, we don't attach anything else, because technically you're supposed to attach an ln of whatever the bottom thing is, but ln of e just goes away, it's 1. So here I need to also attach an ln4. Does everybody see how that actually matches e then? They just reorganized it, so it's negative ln4. They just put all this out front, right? They moved this guy out front and then took it times 4 to the negative x. Any questions on that one?
So you just add an ln,
Yes.
take the derivative of the top.
Good.
Okay.
So these formulas are like y equals 3 to the x squared, you know, this would be something like e to the x squared attach a 2x. You got to attach the inside. The derivative of anything, let me just put 6 to the x squared. This would be 6 to the x squared, attach a 2x, but also attach an ln 6. So whenever it's a number in a base besides e, you got to attach the ln of that. Do you guys remember your log derivative formulas? What's the derivative of ln?
1 over
1 over x.
Perfect. And if there was something else in there, you know, if this was 1 over, it was ln of x squared, it'd be 1 over x squared, and then attach the 2x to the outside, right? We can simplify that. Do you guys remember your formula? If it's a log that's not, I'll just do regular x right now. Actually, no, I'm going to do x cubed, just for the fun of it. Do you guys remember what it is if it's a log that's not ln?
No.
1 over like x cubed. And then you have to attach like the log of that number or something.
Yes. So basically, like on this one up here, we attach the ln 6. Down here, you attach an ln 6, but you attach it to the bottom. And then when you attach the derivative of the inside, it still goes off to the side. So this 4, you know, I've got this recording, so you can come back and look at it or just take a picture quick. Like these 4 formulas, my guess would be that all the trig ones are probably still somewhat handy in your brain, right? You're like, oh, derivative of tangent is secant squared because you've been using that as we've gone backwards. But we have not gone backwards from any of these. So maybe those are the ones to probably put back in your brain. Everything else is probably still there. Nice. Number 7. The graph below represents the derivative. Ooh, okay. Where f of -1 equals -2. So they give us this information. And they say that's a possible graph of regular f. So notice what they give you, this thing that they give you here, is the derivative. So this is the derivative that they're giving you, right? It looks something like a parabola here. And they want the original. Now, I'm probably not going to give you one this hard. Like, I might give you something that looks like this for sure. But I'm not going to give you guys one this hard because basically kind of come back to yourselves. Don't look at this one for a second. But you guys know that let's say that there was just a line. When you went backwards, wouldn't that become a parabola?
Yeah.
You guys remember that? And then if it's a parabola and you go backwards, what are you going to get?
Go back for a parabola, don't you get a line?
Cubic.
A cubic, yeah. Forwards from,
Oh,
yeah, so backwards from a parabola would be a cubic, and then backwards from a cubic would be like a quartic. Everybody with me, how it kind of goes up?
Yeah.
So that's probably more likely what I'll give you is I'll just give, this one's kind of gross because they're giving you a line and a parabola and expecting you to do both. So that's kind of nasty. I will just give you one or the other and you gotta know what to do with it, right? But if we take a look at this, this is a little bit interesting because if you guys see this information that they give you right here, there's no prime in it, right? It's not like they put a prime right there. This is just this. So even though you come down here, you're like, oh, maybe this is telling me about this, because this is at the point -1, -2. I mean, it's open. That is actually, this thing though right here is actually telling you about the original because it doesn't have a prime in it. So that actually tells you that the point -1, -2 is actually a point. So that's where I'd start. If they give you a point, make sure you do that. Now let's take care of the line first. This is a line, and isn't it the line y equals -2?
Yep.
mm-hmm.
And that's actually something that we could write. So we could even go backwards from that. What's backwards from -2x? Or what's backwards from -2? Sorry. -2x. So this is actually a line that, like, basically this will turn into a line that has a slope of -2, right? Should it be down like 2/1, down 2/1. So that's what this is going to turn into over here, but it has to hit this point right here. So I just got to make a line that's got a slope of -2. But it does have to hit that point just because they told us about that point first. Now, from here, it actually can jump anywhere because we've got kind of a jump going on here. But it's good to remember what parabolas mean, because if we don't know since we don't know the equation of this parabola, we don't know if it looks like this or something. We can't go backwards because we don't know. But we do know it's going to look like a cubic when we're done. And do you guys remember, like, what's the important things to look for on this parabola right here?
Points where
The x-intercept.
Yeah, right here, those are going to become our max and mins, right?
Yeah.
So at 0, we're going to have a max or a min, and at wherever that is, 2, it looks like, we're going to have a max or a min. Nice memory. So the question is, which one's which?
it's positive. So isn't the 0 the max?
Yeah, so this is positive, this is negative, this is positive. So it's going up, and then down, and then up. So that means you can start from this point if you want and go up, or technically you could even start from here and go up, because it says there's more than one possible graph. So you can go from wherever you want. We just had to make sure we had that one point in there. I'm just going to go ahead and start from the point, because why not? So you got to go up, and then you hit 0, you hit the axis, and then you got to come back down, because this has to be your max. And then at 2, you've got to get to a min, and you've got to come back up. Now, you guys can make that as big or low as you want, right? You can go up here, and then you can go all the way down here if you want, and then up. That's fine, as long as your max and min happen at 0 and 2. How do you guys feel about that?
Good.
Great.
Sweet. And basically, if you guys want to know on your final, I probably would not give you something that looks like this. I would probably only give you the parabola, and you would have to do something that just looks like the cubic. How do you feel about that?
Sounds
Even
good.
better.
So
Sweet.
could those max and mins be as big as we wanted to?
Exactly. As long as they happen at 0 and at 2 on the x-axis.
All right.
All right. Number 8 is number 8 again is a perfect topic that this is going to be on your final, but I don't think I'm going to give you one that's as nasty as this with an e and an x squared in it. But the great news is, everybody, is that you have your calculator at your advantage. So if you want to double check, this is where we're going to make our charts of where things are increasing, decreasing, and things to find out, our intervals and such, we did those before, and we're going to find out where things are concave up and concave down and points of inflection and such. So we're going to do that. But if you want to ever double check yourself, literally just plug this bad boy, just graph it, it's the original, and see if it looks like it has a max where our chart says it has a max, right? And you'll know that you're doing it right. But let's see if we can sketch it first. That's kind of what I would like to do. So let's take the derivative of this thing. What is the derivative? Because we got to solve this first, of this bad thing.
1 minus 8 or plus 3, right? Doesn't it change to plus?
Yeah, I think it's going to do plus 3. And then don't we have to attach a
Yeah.
2x?
Yeah.
And then we essentially have to set this equal to what? Do you guys remember?
0.
Yeah, which this is why I'm like, is this even solvable without a graphing calculator?
Would it be a negative 2x?
It
or
was
is
decimal
positive?
the whole way when I did it.
Yeah, so I'm going to give you one that's not even this, I'm not going to give you one that's that gross with decimals. Gross. Well, with that being the case then though, what I would probably do if I was you guys is I would probably graph this. I'll bring up my graphing calculator and switch the screen around just so you can see it really quick. I would probably graph this and figure out where it crosses the axis, right? Because where it equals 0 is where it crosses the axis. So that's probably what I'm going to do, because it's just gross decimals. I would give you one without an e in it as well, so it was actually solvable, but that's unfortunate. Ew. So let's see here. I'm going to graph this guy. So 1 plus 3 e to the, oh, no, I'm not graphing the original. We can graph the original later, but 6x e to the negative x squared. All right, so I'm going to go back to Zoom, turn off the screen share for a minute, and flip my there we go. I don't know about you guys, but this is what I see. Do you guys see? When you graph this bad boy. And then I'm going to go to calculate the zeros and just figure out where this thing crosses. At negative 0.17 is one of them. That's really nasty. And then I'll calculate the other one. Negative 1.47. You know, I'm tempted to just, you guys can tell me what you want to do. So basically we got negative 0.17 and negative 1.47. Do you guys want to finish this one, or do you guys want to see one that's more like what you're going to see on your exam that's not as nasty of decimal numbers?
More on the exam.
Okay, so let's do, so just like, be like, that was fun. So we're going to do a substitute for number 8. Because that one was a little bit too tough. Because it's just going to be something that would be like a normal, you know, quartic or something like that. So let's do, I don't know, this. So boom, here we go. What's the derivative of this?
We can't see it.
Oh, I didn't. Sorry. You're like, I just see, do you just see my leg right now? That's probably what you see. Yep. Sorry about that. Here we go. Thank you, Abby. Appreciate that. Everyone else is like, I'm just going to walk your leg. That's fine. All right, everybody can see that now?
Yeah.
Sweet.
Yeah.
I don't know if this works out perfectly yet, but we're going to go with it for right now. So what's the derivative of that?
4x to the third minus 12x.
Nice. And what do you guys think? Can you guys solve that? Is that nicer?
So. Oh yeah, actually. Take out a
I mean,
4.
way better than it was. And that's going to be, so that's going to be more like what you're going to see on your exam, is something that's solvable like that. I mean, you can still go to your calculator and graph this and see where it crosses. But if I pull out a 4x, I'm left with what? X squared minus 3. Is that true for everybody?
Mm-hmm.
And so then what do I get as my answers here?
0 and plus and minus root 3.
Nice. So I'm just going to set both those equal to 0, and I get 0 and plus or minus root 3. And then you guys remember, this is how we make our chart. We just haven't done this for a while. So this is where we say, oh, our interval's from negative infinity to negative root 3, and then from negative root 3 to 0, and then from 0 to root 3, and then from root 3 to infinity. And it's just been a while since we made one of these charts. So do you guys remember, what do we do to finish this chart here?
Just plug stuff in.
Yes, what do we plug it into?
And
Yes, at first, right now, we're looking for f prime, so we plug it into the derivative, and we can see if it's positive or negative. So what, negative root 3 is like negative 1 point something. So what happens if we plug like negative 3 into the derivative? What do we get? Negative
Get a
27.
negative number.
Yeah, definitely negative. And you can use your calculator all day long, friends, now, because you got your calculator for exam. What happens when you plug negative 1 into the derivative? Don't you get a positive number?
Yeah.
Negative 4 plus 12 is positive. What happens when you plug a regular 1 in?
Negative.
Negative.
Negative. And then if you plug like 2 or 3 in, you're going to get a positive, right?
Positive.
So do you guys remember, this is where you put decreasing, increasing, decreasing, increasing? Does that look good for everybody?
Yes.
So now we've answered parts A and B. A and B were increasing, decreasing. It wants to know where there's local extreme values. So where are the max and mins now that we have this on our chart?
Every time it changes from decreasing to increasing.
Yes.
Same.
No, that's a min, yeah. So decreasing and increasing would be here. So isn't there a min at root 3? Or at negative root 3? And there's a min here at root 3. And there's a max at 0. Now, if it just says where do the extreme values exist, then you're done there. If it wants the actual point, you would have to plug those numbers into what?
Original.
Yes, so this would be like 0, 8. Bless you. In a second, while we go on to this second derivative, I'm going to go ahead and graph this just so that you guys can see how to double check yourself, because we'll graph the original and make sure it lines up. But let's find the second derivative to do the second chart. So what's the second derivative, friends?
12x squared minus 12.
Nice. Pull out a 12 and you get x squared minus 1 and solve that. And what do you get? X equals?
Plus or minus 1.
Nice. So why plug this in the graphing calculator? You guys make your chart really quick. So this time you're plugging things into the second derivative and seeing what you find out. So you got to go from negative infinity to negative 1, from negative 1 to 1, and from 1 to infinity. Do you guys get plus minus plus? That's good for you guys?
Yeah.
And what does that mean? We don't write decreasing and increasing now. What do we write?
Up, down, up.
Concave up, concave down.
Perfect. And then would you guys be okay with the fact that we have POIs at x equals plus or minus 1?
Yes.
Boom. And so now, hopefully I will remember to share my screen again so that you guys don't have to just look at my leg next time. But if I flip my camera, that's the graph of the original. It looks to me like it's got a min at negative root 3 and at root 3 and a max at 0, 8. And it looks like it's concave up and then concave down and then concave up. So does everybody see how they can double check there? You guys are doing great. And I will say, I apologize that I'm kind of like roaring through today, but it's since I've got a Zoom meeting at 11 with my Alge 2 folks. That's kind of just what I got to do. We should have more time on Thursday when we Zoom it too, to just kind of take a little bit more extra time if we need to. But, oh, that's not what I want. All right, so we're on to number 9. Number 9, it says use the graph of the function to estimate where f prime and f double prime are 0, positive, and negative. So just so you guys know, this is a lot like it's related to the one we just did, except for you aren't finding where it's all those things. You are looking at a graph that they give you. So let's see here. You guys still see my screen?
Yeah.
So this thing, I mean, you guys are probably going to want to look at your paper more than this thing because it does something, you know, like this and like this and like this. And I'm not going to draw it perfect. But for part A, it wants to know where f prime is 0, where f prime is positive, and where f prime is negative. And then it wants to know the same thing for f double prime. But do you guys remember that f prime is related to increasing and decreasing?
Yes.
So where in the world is this thing increasing if you guys are looking at your graph?
From like -1 to 1 and about
Yeah.
to infinity, I think.
Yeah, -1 to 1, and then I would agree about 3 to infinity. So that is why I just put this under where it's f prime is positive, right? Because it's increasing from here to here, and it's increasing from here to here, and we use x values, right? -1 to 1 and 3 to infinity. And then where is it negative? That's wherever it's decreasing. So decreasing here and here. Would you guys agree that that's like negative infinity to -1 and like 1 to 3? So where does that mean it's 0? Where is f prime 0?
At -1, 1, and 3.
Yes. So how you do that is you look for the max mins, right? That's where the derivative is 0. You look for where it's positive and negative is the same as where it's increasing, decreasing. Boom, and now we are on to the second derivative, but doesn't second derivative have to do with where it's concave up and down?
Yeah.
Sweet. So, where is this thing concave up or down?
Negative infinity to 0. It might be concave up.
Yeah, I'm kind of feeling that. Negative infinity to 0. And that's I'm putting under positive because concave up is where it's positive. And then would you guys maybe say like, I don't know, like 2 to infinity
2.
again? Yeah. And then that would mean it's negative just in this little area right here, right?
Mm-hmm.
So from negative or from 0 to 2. And then that means it's 0 at 0 and 2. Nice. So just remember that this has to do with concavity and this has to do with increase, decrease. Nice. Any questions about number 9?
Would you take off points if instead of infinity we put 5 because ours doesn't have arrows? It just stops.
Oh, really? Oh, yeah. I would not. So Julie, I would not take off for that, but be careful. You'd have to use x values. So 5 is the y value. So you'd have to say something like, from 2 to 5 for the right side, and then like from negative like 3 to -1 on the left side because you have to use x values. Does that make sense?
Yeah.
Cool. Yeah. So I wouldn't take off if you used x values or infinity. Good question. Numero 10. You're planning to make an open bath from a 30 by 42 inch piece of sheet metal by cutting congruent squares from the corners and folding up the sides. You want to have the largest possible volume. Everybody, if I draw this, does that look familiar for this thing?
Yeah.
Yeah.
Sweet. Do you guys remember what the formula is for it?
X times 30 minus 2x times 42 minus 2x.
Nice. Because these things are measured x, and so if you cut them out and folded them up, if this was 30, you'd be taking out 2x, and that would be your length. If this was 42, you take out 2x, fold up your length, and then x would be the height, right? So this is like length times width times height, but I'm putting the height first. Boom. Now, everybody, here's the great news. This is your equation. For part A and B of this thing, it actually just wants what size square. So what size square is like, they essentially want what x equals. And part B is what's the largest volume. My friends, this is where you have your calculator at your disposal. We can do this the calculus way, and we could solve it, set it equal to 0, find where it's increasing and decreasing, find the max and min, or we can just use our calculator and find the max. How do you guys feel about that?
Calculus.
Calculator.
Shut up, Will.
Will's doing the calculus. Everybody else, I'm plugging it in, you plug it in, and see if you get what I get. I'm not going to go back to my screen. So I'm just going to go to my y equals screen, plug x minus, and then 30 minus 2x, and then 42 minus 2x. My bad. Friends, as I'm looking at the time, I don't know if we're going to quite get to 17. I mean, we might get close here as we keep moving because we got 15 more minutes. If we don't, do you guys want to do just tomorrow morning at 10 as well, which means we wouldn't have to cram as much in on Thursday?
Yes.
Sure.
Sure.
Yes, please.
Cool. And then if you can't make it, I am recording, so I'll put it up. So we'll get through a third of it today, which is fine because that gives you guys less to think about every day. Then you go back and just review, each day. So I think it'll be good. So we'll do an hour today, tomorrow at 10, Thursday at 2, actually, because then we can just go as long as we want. I won't be cut off by having to Zoom with another class. And then Friday at 2 is your final. And I did just verify that yesterday, so we are on for Friday at 2. Okay, so when I hit graph on this bad boy, actually, you know what? I will share my screen just because now we have time. So I'll come back here and go to my camera. So I don't know about you guys, but when I graph this right now, this is all this looks like. You remember you have to go back and change your window. So I'm gonna leave it as -10 to, well, I'm not gonna leave it as -10 to 10. I'm gonna go -10 to like 50 because 42 was that one side. And then I'm gonna do -10 and the Y max is probably gonna be huge. I'm gonna start with 20,000.
X can't be bigger than 15.
Oh, that's true. Because it would have to be half. I like it. We're gonna go 20. Oh, so 20,000 was a little bit too big. So if you want to go 10,000, that might be fine. Let's see. Oh, it just.
How you doing, Will?
Yeah, Will, did you decide to do it?
No, I didn't. I was joking. I'm
I did
mostly
it the calculus
watching.
way because I forgot that calculators were a
Fake.
thing.
Fake.
I
Will's
haven't.
fake.
Okay, I didn't do any of the review before this. I'm just kind of watching and working on other stuff.
Hey.
I forgot that you could do it the easy way, so I did it the calculus way, and then I did the calculus way again because I missed a negative in like the first step my first time through, and it was bad.
Did you get this? 5.75?
Yeah.
Nice, because you had to use the quadratic formula, right?
Yeah.
So everybody,
Kinda
of the
gross.
things you see on my screen here, which one of these is part A's answer? Which one's part B's answer?
The X would be part A, the the Y would be part B.
Perfect. This is the X value, so 5.76, and then 3,244 would be the volume. Nice. Let me go back to that. Oh my gosh. Switch it. All right, so part A, yeah, so 5.76. And just so you guys know, the final is supposed to be an hour and a half, like normal. I would say make sure that you plan on having an hour and a half, but since we're doing a very weird thing where, we're remote learning and it's a little bit tougher, I will give you as long as you need. So if the final ends up taking you 2 hours, it takes you 2 hours, maybe not more than 2 hours because then you might just be frustrated by that. But so everybody, number 11 and 13 might be the last ones that we have time for before Ouch 2 logs on. Because number 11 is short, but number 13 is long. So number 11 says find the linearization of this. I took off Newton's method because that is definitely something that's not that big of a deal. But I did not take this off because, do you guys remember that linearization is the same thing as what?
Tangent?
It's a tangent line, but it's rearranged stupid.
Yeah, so it's just the tangent line, but you have to put it in y equals mx plus b. So let's find the tangent line. How do we find the tangent line?
With the slope.
Yep, how do we find the slope?
Derivative.
Nice.
Then
So f prime is what, 12x cubed minus 15x squared? Is that right?
Yeah.
And then we plug in the 2. 2 cubed is 8. 8 times 12 is 96. 4 minus 60. Did you guys get 36 for the slope?
Now I do.
Sweet. I mean, 3 of the choices have 36, so that's always a plus. So then I do y minus blank equals blank x minus blank, right? Like I'm doing a tangent line. 2 goes here, 36 goes here. How do I find the y blank?
Plug it in the original.
Boom. So if I plug 2 into the original, I don't want to use yellow. 2 to the 4th is 16 times 3 is 48 minus 2 q 8 minus 40. So I get 8. I think. Nice. And then I just have to put it in y equals mx plus b form instead. So I distribute the 36. So I get 36x minus 72. And I'm going to add the 8 over here. So plus 8 plus 8. Y equals 36x minus 54. Choice E.
Yeah.
Wait. Rock on. Anybody have questions on number 11?
No.
Wait. Number, if we can get to the end of the page, that'd be great because 14 is so easy. Let's see. 13, everybody, I will tell you that I am not going to give you some crazy formula that you don't know. So I'm actually going to tell you right now, we're not going to do part B. So if you did part B, you can double check on your own, sorry. But part A and C are fair game because you should know the volume of a box. It's length times width times height, right? And part C gives you the formula. So that's nice. Now this is one of those ones, you guys remember the one with the Pythagorean theorem where you had to like, instead of using a squared plus b squared equals c squared, you like took the derivative of it and it was like 2a dA dt plus 2b db dt.
Yeah.
Uh-huh.
Mm-hmm.
That was for like the dog swimming towards the beach, wasn't it?
Say that again?
That was for like the problems where the dog swims towards the beach.
Yes, or we're in our kayak going.
Right?
Yes, exactly. I like it. And I should use an XYZ, I guess, instead of an LWH. So A is actually probably uglier than C. But basically, if you notice, they give you at the beginning of the problem, they give you, I'm going to put stuff off to the side here. They give you dx dt is 4. They give you dy dt is 0. And they give you dz dt is -3. And they give you x, y, and z at the bottom, which is 10, 8, and 5. So we just have to basically, for both of these, we just have to take the derivative and plug stuff in. So how do we take the derivative, though, of this volume formula? That's tough.
Where, you have to do like product rule, but twice, but not really because y is a constant.
Isn't it just the? Oh yeah.
Yeah, sadly we have to do some product rule. And I will say, yeah, Emma, you're right. We could potentially cut down our work since we know that dy dt is 0, but just so that kind of everybody gets it, I'll show you guys that. But that is a good point, so I like that. So it basically means we have to take the derivative of x, which is dx dt, with yz left alone, right? But then we have to add x left alone plus the derivative of yz. So the derivative of yz is another product rule, right? The derivative of yz is derivative of y is dy dt times z plus y left alone dz dt.
Gosh.
That was. But the great news is, as soon as you have, I mean, that's really nasty. I'm going to make you guys do the second one because there's an easy way to do it. But as soon as you have that, you can just start plugging in stuff, right? So I'm going to plug in dx dt is 4, y is 8, z is 5, plus, and then x is 10, dy dt is 0, z is 5, plus y is 8, times dz dt is -3. So I just plugged all that in. And then 40 times 4 is 160, plus this is 0, so if I take 10 times -24, I'm going to get -240, I think. I get -80. Can anybody verify -80?
That's what I got.
Nice. Now, friends, there's an easy way to do part C. And I will be nice to you that I won't set it up like this so that you can see this on your final, that it looks like this instead. If you write it like this, it's like the Pythagorean theorem with one extra thing. If you write it as it was, then you have to do the chain rule and it's just the worst, right? So if I write it like this, hopefully you guys are good to go. What's the derivative of this equation?
2x times plus 2y plus 2v.
Close.
2s ds dt.
Yes.
What?
There we go. We got to have the dy dt's in there, plus 2z times dz dt. And all of that equals 2s times ds dt. And we're looking for this, so we will have to divide everything by 2s. Get that out of there. So then we gotta, I gotta go let somebody in. So we gotta plug all that stuff in, but my question for you guys while I'm letting somebody in is, oh, Ethan has entered. Yep, I guess we're just gonna be able to finish this one. I'll admit him, and then I'll tell him what's going on. Ethan, we're still doing calculus. Come join us, my friend. Okay, and then we just got to plug everything in. But do you guys remember how to find S?
Plug it into the original formula.
Yeah, just do 10 squared plus 8 squared plus 5 squared, and then square root that. That's the square root of 100 plus 64 plus 25. So square root of 189, is that right?
I think it was like 13.75 or something.
I like it. So then I've got, is it okay with you guys if I get rid of the 2's?
Yeah.
Yep. Okay, x times 4 plus y is 8 times 0 plus z is 5 times -3, all divided by 13.75. So that goes away. So then you've got 40 minus 15 is 25 divided by 13.75. Anybody want to give me the final answer there?
1.818.
I like it. Go with it. So everybody, I would say the hardest ones that we have so far are 1.818 and well, this one was gross, but we switched it. Number 8, make sure you look at our new one. And then number 2 is not going to be that hard. So number 1 was a good one to look over. I would look over something like number 1 again, and then some others. All right. Okay. I guess I'm kicking you guys off because everybody's in my thing. So calculus people,
Later.
You guys are out. Peace, dudes. See you tomorrow at 10.
Bye.